For over a decade, every measurement came back wrong. Not slightly wrong, 100 times wrong. Hubble had been averaging 2 different atmospheres as one. The gravity matrix. Today we follow that error and its consequences. At the gravity matrix, this dataset stopped us cold. The paper appeared in Science Mukherjee Singh, Johns Hopkins. How do instruments get exoplanet chemistry wrong 100 times? Hubble averaged 2 completely different hemispheres as one atmosphere. The morning side choked on clouds of vaporized rock. The evening side perfectly clear, open to deep space below. JWST tracked ingress and egress, 11 years exposed. Every Hubble-measured exoplanet may carry the same systematic bias. WASP-94A b sits 700 light-years away, in the constellation Microscopium, a gas giant orbiting closer to its star than Mercury. Tidally locked, one face in permanent starlight, one darkness. Before JWST, every telescope averaged both limbs into one signal. Ingress, the planet's morning side crosses the star first. Egress, the evening side exits last, carrying different chemistry. Sagnik Mukherjee noticed the transit signature was internally inconsistent. He spent months building a model separating both limbs. What did NIRSpec find? A planet that was 2 planets. The morning limb, cloud-dominated, dense, masking the atmospheric chemistry below. The evening limb, clear, transparent, showing the actual chemical fingerprint. The cloudy morning side dominated the averaged Hubble signal. The result, hundreds of times Jupiter's oxygen apparent. JWST's clearer evening limb view shows reality, 5 times Jupiter. David Singh's team then checked 8 additional hot Jupiters. WASP-39b and WASP-17b showed the same asymmetric pattern. The pattern is not unique, common among hot Jupiters. The measurement bias was systematic, woven into published literature. Let us return, not to the planet, but clouds. Magnesium silicate is not exotic chemistry. It is ordinary rock, talc, olivine, the same mineral family as Earth's continental crust. On Earth, these minerals solidified billions of years ago. On WASP-94A, those minerals cycle vapor and cloud daily. Here's the physics from inside that alien atmosphere. The night side chills to temperatures where rock vapor can condense. Equatorial superrotation winds carry mineral particles toward the morning side. At the morning terminator, they cool and condense into cloud. Those clouds reach dayside temperatures above 10 degrees Celsius and dissolve. This is not weather in any familiar sense. Earth clouds, water vapor condensing around aerosol particles. WASP-94AB's clouds are rock vapor at intuition-breaking temperatures. Wind speeds on hot Jupiters reach thousands of kilometers/h. That mineral transport system feeds the morning cloud layer daily. What catches our attention? The elegance of this error mechanism. The error was not random. It was structured, consistent, predictable. The most dangerous error. The kind that looks like signal. If this reshapes how you read the night sky, stay. What planet gets daily rain made of vaporized rock? WASP-94AB is tidally locked, one face permanently lit. Nightside winds carry cooled minerals around to the morning terminator. They condense into magnesium silicate, Earth's talc, at dawn. By dusk, the star's heat vaporizes them. Daily. At 10 degrees Celsius. This cycle hid a measurement error for 11 years. Here is the micro-revelation that changes everything, the CO ratio. Its carbon-to-oxygen ratio of 0.9 sits below the star's 0.68. That ratio encodes a formation story wherein the disk, substellar CAO, suggests pebble accretion at large orbital distance. Then the planet migrated inward across the entire protoplanetary disk. But WASP-94AB doesn't orbit normally. It orbits backwards. A retrograde orbit cannot form in a standard protoplanetary disk. It arrived via the von Zapel-Kosselidov binary gravitational mechanism. WASP-94 is two stars separated by two 700 AU. Each hosts a hot Jupiter, a dual hot Jupiter binary, both formed from the same disk, migrated by different routes. In our assessment, this system is among the most information-rich. But formation history is not the story that stops us. What stops us, this era's meaning for every catalogued exoplanet. The turn is coming, and when it arrives, everything changes. Here is what JWST reveals about the atmospheric metallicity. Metallicity at 2.17 times solar, matching the host star. That stellar planetary alignment was invisible to Hubble's blended signal. Hubble-era measurements inflated metallicity by roughly 100 for some species. Not a rounding error. That is a different planet's chemistry. This is where we draw the boundary the data requires. C's O ratio error bars remain substantial, plus 0.8, minus 0.13. The team acknowledged observational uncertainties that still warrant watching. Peer-reviewed in Science, not a preprint. That distinction matters. We distinguish established results from provisional ones. This one holds. Now the key question, does this bias affect habitable worlds? Hot Jupiters, easy targets, large, close to their stars. Smaller planets, super-Earths, sub-Neptunes, are the biosignature candidates. Many tidally locked habitable zone worlds show day-night temperature asymmetries. Cloud asymmetry here, physics suggests, contaminates all data. A biosignature reading from the wrong limb shows false oxygen. We say not fabricated, we say re-examine the data. 218b, a top biosignature candidate, relied on Hubble. JWST has now observed K218. The picture is more complex. The pattern, JWST, reveals what Hubble was averaging past. Dr. David Singh spent 2 decades building the observational foundation. When JWST data arrived, his team first checked instrument error. Not the instrument, both limbs were genuinely that different. 3 independent checks confirmed the asymmetry. Not noise, signal. This is the watershed, the most consequential implication discovered. We may have misread biosignature candidates for over a decade. Hubble's method was applied to TRAPPIST-1, LHS 1140b, dozens more. This doesn't mean biosignatures were false. Measurements need revisiting. JWST has already begun re-observing several of the highest priority targets. What if every Hubble-era exoplanet atmosphere catalog entry is wrong? Same bias appeared on WASP-39b and WASP-17 there. 3 planets, same error. Physics suggests this is common. Smaller habitable worlds transit the same way. Bias applies equally. A limb-contaminated biosignature could look exactly like a false positive. We don't yet know how deep this runs. We first flagged this in early WASP-39 JWST analysis results. When we first saw this spectrum, we read it twice. The implications for SETI and NA, ASA habitability, are non-trivial. Every single limb transit averaging mission must account for this asymmetry. The physics community is responding. The accounting is just starting. Pull back from the data. Consider what this moment represents. Since Voyager crossed the heliopause, instruments have kept expanding. Each new instrument reveals which old facts we measured incorrectly. Hubble measured what it could. JWST now sees further. This is not failure. This is science working correctly. The Hubble tension. CDM anomalies. The K218b debate. WASP-94A. All symptoms, instruments now good enough to see the cracks. This is the decade's most significant scientific shift. We are not in crisis. This is a golden age. WASP-94A is 2026's most instructive exoplanet dataset. Here is the framework, what to watch for next. Watch JWST's limb-resolved observations of TRAPPIST-1e and 1f. If limb asymmetry appears, every prior biosignature reading needs re-evaluation. If the limbs are symmetric, the existing catalog survives. The data will decide. One of science's cleanest near-term questions, the Roman Space Telescope, launching in 2027, extends this widely. Mukherjee's retrieval method will become standard for future transmission observations. The legacy, not one corrected planet, a corrected method. Sagan called science a way of thinking, not only data. Finding your own errors first, that is exactly what happened. Sagnik Mukherjee was a postdoc when he noticed the inconsistency. That is actual science, not the headline but human noticing. Consider what rock rain tells us about our own chemistry. Those alien clouds contain the same material as our ground. The universe reuses the same periodic table on every world. Earth's kitchen counter rock rains from the sky 700 light-years away. That is precisely what it means to share a universe. We don't yet know if habitable zone worlds carry this bias. For the smallest worlds, we may never know. Brutal reality. JWST gives us the capability to ask this question precisely. The generation with the right instruments is alive now. Those who watched Apollo launch now watch JWST data arrive. The questions are bigger now. The instruments are catching up. WASP-94A's rock rain is beautiful in its alien way. For billions of years, rock condensed there each dawn. Every evening the star's heat dissolved it back, relentlessly. We found that cycle hiding inside an instrument averaging error. More cycles hide in the catalog, more worlds to read. Full investigation, biosignature implications pinned in the comments. We track every JWST release. Full breakdown pinned in comments.